Hello everyone, today I'm honored to present our group's brilliant design device, wearable fall detection device for the elderly here. First of all, as we know, there has been a growing interest in the field of falls for the elderly in the last 20 years, and it is estimated that about 34% of the people over 65 years old experience at least one fall per year, and the prevalence also increases with age, as shown in the figure. At the same time, falls can have serious consequences for the elderly people. About 1% of the fall victims experience a femoral fracture, with one-year mortality rate of 20 to 30% and a negative impact on functional ability. And 30 to 70% of the patients will develop a depressive syndrome due to the fear of a new fall, leading to the disability and hospitalization. Therefore, the prevention of the falls and the protection of the elderly people from falls are of great importance. So what do we need to better help older people who have fallen? For the elderly, immediate treatment after a fall and an alarm system is essential to help them receive the timely assistance after a fall. Also, to make the device more user-friendly and easy to use at home, we added health monitor to check the health condition for the elderly, and daily health information is expected to be linked to the user's medical record. And all these above functions will be based on the detection of the ECG signals and the user's displacement to make a determination. And this is the flow chart of the main design of our protection, where all functions are concentrated in one chip, and the device consists of 3 sensors and multiple outputs. And the ECG signal is the main trigger condition of the device.
As for the hazard analysis, the first one is an NMI rule. The mounting keyhole on NMI rule is very sensitive to electrostatic discharge, ESD. Therefore, when handling the equipment, be careful not to touch the inside of the keyhole. Otherwise, there will be a risk of electric shock. NMI rule has not obtained the certification for use in hazardous areas. In many countries, there is a lack of relevant laws and regulations to regulate its specific use. Although its use in our project does not belong to the service in hazardous areas, it will be used in dangerous situations, such as falling, so there will be some uncertainty about the dangers. These uncertain risks and need to be further tested, considered, and confirmed in the future. The second term is the equipment. As for now, the semi-finished equipment has many potential safety hazards due to the bulky size. When the device object or user falls, the corners and the hard packing of the device may cause secondary injury. This hidden danger needs to be solved urgently. In addition, the equipment is still wired, so trial wires are also one of the inducements of potential electric shock risk. They also cause some inconvenience to users, such as getting entangled with clothes. The equipment size, weight, and wiring can be reduced using a more miniature triaxial accelerometer and a wireless transmission link device to reduce such hidden dangers effectively.
For the software aspect, our project software is constructed based on the lab build. And the general idea for the software is, firstly, we're gonna determine the fall condition based on the changing height, we're gonna see if there is a rapid height changing in a short period of time, because this is gonna separate between a falling condition or whether the patient's just sit down or doing like a slow motion. This is the lab view block back window. So on top left corner, HB, which is the bell height, will output into the sequential block. And this sequence block is gonna save each belt height at that period of time, and minus the previous one. So then this is gonna output the changing height, like the magnitude of the height changing, and then we're gonna determine whether if this changing the height changing is happened in a short period of time, which is what the loop is doing below it. Well, on the final true or false condition, there are many extended functions can be added in, such as if we can add in alarm sounds, or send a message to a doctor, or any other useful function.
For test, firstly, we should calculate the false set value. We repeatedly free for my real from the belt height to get the falling value and average it as the set falling value. We verified the device under 4 different movement models. Normal works, slow run, scratch, and fall. We can see that the device can correctly identify the fall behavior.